This cranked up here. I wrote myself some extra notes, or I wrote you guys some extra notes on this copy, but I've already kind of done the work for the rest of this, so I'll just kind of slowly explain it and show you what I've done. But to get started on 15F, what is the measure of the center, which, take it literally, it's the approximately half of the values on the left and the right. So a perfectly symmetric curve would have this. But the spread is just another word for range. We'll talk about that in a minute here. So let me uncover the answer based on that. Let's see, letter F. So it says, what measure of center, don't pay attention to Q1 that has to do with this, and spread best describe the data. So in this situation, you can see approximately half of the information's on the left, half the information's on the right. So we look at our mean, and our mean, does that represent our center? Yes. So we can say the mean best describes the data for our center. And then as far as what works on this sort of curve, which we would call a normal or bell curve if you kind of convert it that way. That wasn't perfect. But standard deviation works for only these that are considered normal distribution. So I know that's a mouthful or a brainful, but that's basically what they're asking for. And what's interesting is the median is also 21, so you might be tempted to say, well, the median also works, and you're not wrong, but in this event the average happens to be the center, so we can use standard deviation. Now there's another example where we're going to have to use median as our answer coming up, and you'll see why. So let's go on to the next question. So it says, using the data below, answer the following questions. So as you can see, I've already kind of crossed them off and reorganized them. Once I've done that, I've gone from the low number 35 all the way up to the high number 62. I've made the low quartile pink and the upper orange, and smack dab in the middle is 48. So we can tell that the median number is 48. That jumps right out at us. The minimum value would be 35. Now, I've already calculated the average because I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I snuck that 11th one in right there. So you add them all up, divide by 11, you'll get 51. So keep track of that. That's our average or our mean. Now let's just keep moving along here. What's the range or the spread? Well, it's the maximum minus the minimum. Largest number minus the smallest, 44. Pretty easy. And now, what's the IQR? Well, that's the third quartile, which I've already found to be 59. But let's talk about that. We got 1, 2, 3, 4, 5 numbers. So the middle number of those 5 numbers is the 59. So that's the Q3. Q1, what's the middle number here? Well, 1, 2, 3, 4, 5. Middle one's 41. Subtract that, and I get this number that has value once you get into the deep truths of statistics, which we're not really doing. So Q1 is 41. Now it's just a formula, basically. Q3 is 59, and the maximum number is 79. I'm getting prepared for the 5-number summary, and I've just got it all written down here as well. Now, here comes the meat and potatoes, in my opinion. Create a box and whisker plot. So, remember, you start right here with the median, and we notice that's 48. And then we go down to our lower quartile, which is 41 for the box. Then we go up to our upper quartile, which we said was 59, so I put it right there. And then you notice it goes down to 35, which isn't very far, and then it goes up to 80, which is quite a ways. So you can see the peak is here, and then it's kind of goes down here, and it's skewed to the right. This is not like this. Very different. So this is standard deviation because it works on a bell curve. This is not a bell curve, so that whole language, mean and standard deviation, does not work. So we have to think about it quite differently. It's skewed to the right, and so if we take a look at the mean or the average, that'd be over here, which is not really centrally located. This is the median, and with that being said, the best way to explain it is it's skewed to the right, which means it's not a bell curve, which means you don't use the mean or the standard deviation. You use the median to explain the center because it's more accurate, 48 of the information, and then you use the IQR instead of standard deviation to determine the imbalance of the numbers. So it's just a bunch of jargon that you use for skewed right or skewed left is right here, and this is the jargon you would use if it's symmetric or normal, considered the bell curve. So I hope that makes sense, but the whisker plot helps you determine which way it's skewed, if it's symmetric, and that's the benefit of creating it. So there you go. I know that's a long explanation, but reach out if you have some questions. All right, number 17, the heart rate of a random sample of people is approximately normally distributed. So what that's telling you is there's going to be a bell curve, which means it's going to be normal. Sorry about that, but you kind of get the idea, I hope. That's not perfect, but you get the idea. The mean heart rate is 73 beats per minute. So I'm going to make this little chart down here. I'm going to put 73 right smack dab in the middle, and then let's keep reading. And the standard deviation is 6 beats per minute. So I'm going to go up 6 from here to 79, and just kind of keep going up in chunks of 6 until I'm kind of, there's 1 standard deviation, 2, 3, and then that's kind of the rule of thumb. So then I go down 6, go down 6, go down 6, and the curve would look something like, see if I can make this better, like that. Not perfect, but you kind of get the idea. So it says use this information to answer the following questions. So definitely go from here to here, and this is the key to getting the drawing accurate, because you can draw it like a bell curve. They're telling you have the license to do so, which means this is 1 standard deviation, this is 1 standard deviation, 6 beats per minute. So they're telling you that. So it says, what range of heart rates contain 95% closest to the mean? Well, if you recall, let me stop this a second. All right, so what I wanted to refresh your memory about was this truth about the bell curve. So 95% of all values fall within 2 standard deviations. So you can tell, you know, they want you to remember those specific things, and that it comes within 2 standard deviations. Well, that means from the mean. So that would be, here's the mean right here. So 2 standard deviations would be 61 heartbeats, and then 2 standard deviations would take us up to 85. So 95% of the people would have that sort of heart rate. Okay, so this next one, guys, is a little tricky, but it's not. Give the interval of the data values that would be greater than 84% of the distribution. So we have to know that from here to here somewhere is 84% of the entire 100%. So how do you figure that out? We're going to manipulate these rules. 68%, sorry you guys, fall within this window, 95% falls within this window, 99.7 fall within this window. 1 standard deviation, 2, 3, but on both sides. So with that being said, there's a little drawing. The problem says 84. Now that number's not picked randomly. Think about this. So right up to here is 50%. The halfway mark is 50%. That's what's important about the bell curve and the normal distribution. Because if we go 50% and we know, because all the information is 50%, but we know within 1 standard deviation of the mean is 68%, that means 34 is on one half, 34 is on the other half. Sorry about my spaces here, they're bad. But if we think 50, half, plus 34, what's greater than? Well, that takes us to 79. So that would be 79 or greater for number 17B. I think that's the hardest question on the whole review. Next question is kind of a lot easier. What percent of the data would be between 67, notice there's 1 standard deviation that way, and 79, so that's 1 standard deviation that way. It's what we just talked about. That'd be 68%. So these numbers just kind of show up with great regularity in this. Okay, 2 more problems and we can call her good. Suppose travel times of employees at a company are normally distributed. There it is again. That means we can build one of these, a little bell curve, and talk about it. With a mean travel time of 18 minutes, so there's 18 minutes, and a standard deviation of 3.25, so that would take me to 21.25, and then down to 14.75 minutes, and it says what portion, before we keep going, what portion of the employees have a travel time between 14.75 and 21.25? So you see how they want to really, so this is 1 standard deviation and 1 standard deviation, which takes us up to that problem. It fits within that window, so that'd be 68%. Looks like it's going to be hard, and it's not. Okay, last problem. Keith's score in the card game of hearts is 96, while Bruce's score in the card game of 5 crowns is 296. The z-score for both players is 1. But the standard deviation of hearts is 6, and the standard deviation of 5 crowns is 22. Compare the means of each game. Well, if we just take a look at the formula, remember the z-score, they told us is 1, and that equals, and we're going to talk about Keith first. The z-score is equal to the score minus the mean divided by the standard deviation. And that right there is where I lost it. Oh, right here, 6. Now we're going to multiply that by 6, multiply that by 6. So we're going to get 6 equals, these cancel, 96 minus the mean. If we subtract 96, subtract 96, we get negative 90 equals the negative mean. Multiply both sides by -1, and we get 90 for the mean for that one. And if we just follow the same program for the other guy, Bruce, they have the same z-score, but now his score, where is it, was 296 minus the mean all over the average there, or the standard deviation. Multiply by 22, multiply by 22, we get 22 equals 296 minus the mean. If I subtract 296, subtract 296, I get negative 274 equals the negative mean. So 274 equals the mean. All right. So there we go. They just said to compare the means. There they are. Done. Doesn't really say who played better. Because well, I guess they did. They said the z-score is 1, so they were the same. So I guess that wasn't. All right, that's it. I'll stop babbling. Like and subscribe. These videos are amazing. Reach out if you have questions.